You're listening to Carbon Removal Newsroom, a weekly show about current events in the world of carbon removal, from technology and innovation to policymaking and job growth. Brought to you by Nori, the carbon removal marketplace.
Hello, everybody, and welcome to our Thursday, June 2nd edition of Carbon Removal Newsroom. This week, we are science-focused, and I'm very excited to welcome two guests to my show. Dr. Shannon Valley from the United States Geological Survey. She's a postdoctoral scholar at Woods Hole Oceanographic Institution. Shannon, so nice of you to join us. Thank you.
Thanks. Good to be here. I should clarify, I'm technically employed by Woods Hole, but I am a fellow in partnership with USGS. So
perfect. I appreciate that. Lots of titles in there. And then Dr. David Ho, who's a professor at the University of Hawaii at Manoa. David, so kind of you to join us. Thank you.
Yeah, nice to be here.
Which island is that on at the University of Hawaii?
It's on Oahu.
Okay, nice. I'm heading to Hawaii in a couple of weeks. Can't wait. And then finally, my name is Radhika Mulgavkar. As you all know, I lead the supply and methodology group at Nori. So as people who listen to this podcast regularly know that Ocean CDR is attracting attention from all corners of the climate community. We have focused in recent episodes on the global policy developments in Ocean CDR regulation and research with Will Burns, and some of the business challenges in the space with two startups who were X Prize winners and that are working to develop commercial methods to remove carbon dioxide from the ocean. So today, we're going to complete the trilogy a little bit around CDR, Ocean CDR, to the extent we can, with a look at some of the recent science on the topic, focusing on the outstanding scientific questions that will need to be answered before Ocean CDR can be deployed safely and effectively, a topic that Will talked about from a policy perspective. First, we're going to look at a 2021 paper from D.A. Siegel, which assesses how long carbon dioxide can be stored in seawater will remain sequestered in the ocean based on the given location and depth of the process. Then we'll look at a perspective piece from Nature, Ecology and Evolution from Boyd, Bach, and Hurd et al. The researchers suggest that some possible unintended ecological consequences of proposed large-scale kelp planting, such as widespread drift to kelp into new ecosystems and the spread of invasive species. The authors outlined potential research metrics, which should be established to evaluate the safety of ocean afforestation. So let's jump into that first paper, which was assessing the sequestration timescales of some ocean-based carbon dioxide reduction strategies. Shannon, I'd love to start with you. The piece found that carbon dioxide discharged into deeper water under 1,000 meters will remain in the ocean for much longer than shallow water sequestration, such as increasing upper ocean ecosystem productivity, and will have a shorter climate effect. Can you just basically explain what that means and why it is and how that relates to CDR? Big question probably, but I'm sure you can tackle it.
Sure. So I guess I would want to kind of step back and talk about, why ocean depth should matter at all. I guess it seems like the ocean is all water, and so it should all be kind of the same thing. But actually, the ocean is really stratified into vertical layers based on their densities. So like if you're thinking about kind of different layers of salad dressing, or if you're, going back to your different colors of liquid that are stacked on top of each other, that you may have seen in different science classes over your lifetime, you can understand that the different density layers mean that unless you shake kind of things up, that there's the different properties of those different layers are not going to necessarily mix. And that matters for carbon as well. So you have the surface layer of the ocean that's interacting constantly with the atmosphere and with carbon dioxide in the atmosphere. You have an upper ocean that may be going down to about 1,500 meters or so. And then below that, you have the deep ocean. And all of these layers are circulating at different rates. And there's a whole global circulation scheme of different ocean currents and different ocean layers. And all of these different properties, nutrients, dissolved gases, and so on that are going along with it. And basically, in short, the deeper ocean is circulating on much longer timescales. And what that means effectively for carbon is that the carbon in that deeper ocean layer is not interacting, it's not exposed to the atmosphere for many centuries or thousands of years. And that's kind of dependent on which basin you're talking about. If you're talking about injecting carbon into a different, in the Atlantic versus Pacific, for example, the paper found that, unsurprisingly, that the deep ocean, that carbon injected into the deep ocean in the Pacific takes much longer to interface with the atmosphere, which is when it can release that carbon that was initially injected.
So just to make sure that I understand it, there's stratification in the ocean, like you mentioned. The deeper, the less likely to interact, obviously, with the atmosphere, the longer it takes to come back. But there's also an interplay with where in the ocean you are. So the Pacific and the Atlantic act a little bit differently, or a lot differently, potentially. And can you just elaborate about why that is, what makes them different, and how you identify potentially a good place for deep CDR, for Ocean CDR?
Yeah, so the Atlantic and the Pacific have different kind of overturning regimes. So when we say overturning, we're talking about oceanography. We're talking about water that is that's been at the surface, that again is exchanging with the atmosphere, and when it increases in density because it's saltier and colder, for example, then it's drawn down into the interior ocean and into depth. And eventually that water is also going to it's displacing other water somewhere. It has to go somewhere. And so it will have to then come back up to the surface over time. And that happens in kind of different upwelling regions. And based on a lot of different factors that I won't go into here, but the Atlantic has a more robust overturning regime than the Pacific does. And so that's some of the basin, that's the behind some of the different findings that you see, the different basins that's reported in the paper.
Thank you, Shannon. That was very, very helpful. So David, the timescales of Ocean CDR are being examined range from like decades to thousands of years. I myself have talked to various startups who claim, thousands of years up to millions of years. So if a given CDR proposal is intended to test how long it could sequester carbon dioxide in the ocean, first, how do we vet it, and how do you verify it and measure it? Like, it just seems very overwhelming, but I would love to get your thoughts on that.
Yeah, so before I answer that question, I think it's important to clarify something about this paper and what we're talking about when we talk about CO2 storage in the ocean. So this paper specifically addresses the question of, if you inject CO2 at various depths of the ocean, how long will that CO2 stay there? And that question has some relevance for some of the Ocean CDR methods, like growing kelp or enhancing alkalinity, in the sense that if you can get the carbon that then gets sequestered by those techniques to those depths, the carbon will stay sequestered for that long. But really, this is a two-step process, right? When you grow kelp or when you enhance alkalinity, what you're doing is you're removing CO2 from the surface water. And then the second step is, once you create that deficit, then you draw down CO2 from the atmosphere. And that's your CDR. It's not the uptake from the ocean that's the CDR, right? So this paper really, it's not directly relevant to that question of how long does atmospheric CO2 get sequestered, unless you're talking about something like, you're doing direct air capture of CO2 on land, and then you somehow pump it into the ocean at certain depths, right? And I think that's really, really important to know. So, none of the answers given in this paper, refers to how much of the kelp-derived or alkalinity-derived CDR stays sequestered from the atmosphere. Okay.
So I have a follow-up question before we go to my original question again, which is,
Yes,
so you said that it's the deficit that's created, that's the CDR piece.
that's the potential
CDR piece. Has it even been shown that that one happens? And to the ratio, is it like for every 1 ton that there's a deficit, that 1 ton is drawn down from the atmosphere? Do we know that even yet?
We know that it's definitely not 100%. So we have a student who just presented a paper at the recent EGU meeting in Vienna, where she showed that the global average for kelp, let's say if you consider nutrient limitations, is about 40%. And it varies, right? In some area, actually growing kelp releases CO2 into the atmosphere. So it'd be bad to do kelp-based CDR in those areas. And then there are some areas that are quite efficient. You go up to maybe 70% or more. So yeah, it really matters where you are. So how did she do that? And that gets to the question that you originally asked, is I think we have to use models because the timescale of these processes are so long that there's no way for us to go out there and measure. But what we need to do is make measurements to calibrate and validate models. And then we use models of different complexity, different resolutions to really look at the different areas of the ocean to figure out, this exact thing, how much CO2 would get taken up by one of these techniques, and what are the side effects, what's the efficiency, and how long does it stay sequestered.
I'm curious, Shannon, from your perspective, and is that modeling is what my company Nori does for soil carbon removal, but it is a bit controversial because people feel like it's not the gold standard, which is soil sampling and testing. Some people feel that way. Do you think models will be more accepted within the scientific community of the, or studying oceans than they sometimes are within the scientific community around soil sampling or soil CDR?
I think modeling in general is already well accepted in the oceanographic community as a way of kind of, as David was saying, understanding changes over longer timescales than what we could just measure experimentally or what we could observe experimentally. What the question of like, what is realistic or not? We're talking about just huge geographic space and then huge temporal space. And I think the problem with thinking about these things with climate change is that, right, we're constantly we're in an ongoing experiment with perturbations to this system. And so if you want to kind of forecast and try to understand how some other kind of tweak or some other kind of activity is going to impact things, you really need to do it through modeling. And I mean, that's not the only way that you can kind of answer some of the questions that we need to answer to ensure that the work that we're doing in CDR is both effective and we're doing the least harm to ecosystems and so on. But it's a really important and powerful tool. And it's powerful also because you can start to mess around with issues of scale. That is something that came up, I think, with at least one of the papers that we're talking about. The power with, and I'm sure David has more to say on this, but the power with models is that you can kind of you can play around with the knobs in the way that you can in the real world. And you can make observations and understand exactly what you've kind of, at least what you've changed initially, and see what happens with the system. And then you can kind of push things to kind of their natural limit. The other way of that I've done it in my research is working in paleoceanographic studies, is kind of looking at the Earth system and other types of natural experiments of extremes, like looking at changes from glacial periods to now, and periods when our climate was vastly different from now. But models are a way that you can kind of get at that at real time and run those over periods of, weeks to months, rather than waiting for years to try to understand what kind of intervention would have, what kind of impact an intervention would have on an ecosystem.
Well, that leads me into my next question about this paper, or just generically about Ocean CDR, right? I think some advocates have said that even if there are other ecosystem consequences, these techniques could well be worth it, because, the effects on the ocean from climate change may be worse, or will be worse, than the technique would be, the CDR technique would be. So I'm curious what you both think about that question. And, how do you go about, in your own mind, balancing the risks and benefits of CDR technologies as opposed to the impacts of climate change on the ocean? And I'll start with you, David, and then I'll go to you, Shannon.
Okay, so I'm a scientist, and I sort of feel like this isn't a decision for scientists to make, right? I mean, there needs to be other stakeholders that decide these things. But when I personally think about it, I would want to know what are the side effects of the CDR techniques, and how many people are affected, and what kinds of ecosystems are affected, and those things might be related, right? Like if you damage an ecosystem, then you also affect people. And I'd like to know what is the duration of these effects, etc. So those are the things that I think about. But these are very sort of theoretical, I guess. But I think it should not be a decision that's left for just scientists, certainly.
Shannon, what do you think? How do you approach this problem, either professionally or personally?
Yeah, I totally agree that this is not a decision for kind of one group of thinkers to be making over another's. I think it's a really important question. And again, change is a constant in the Earth system. So when you talk about trying to avoid kind of irreparable harm to ecosystems and so on, it's like irreparable over what timescales, right? So what's relevant to us as humans, as conscious beings on this planet? So, that may be the limits of our thought, and consideration of that may be generational, or, societal eras, or civilizational periods at most, right? So we have to decide kind of what we value from the ocean. What are the things that we want to protect most? So is that, are these coral ecosystems, are these macro fauna impacts that come downstream, or the fisheries that directly impact people's livelihoods and their well-being? And just even, I'm involved with this group called the Inland Ocean Coalition out in Colorado. It's nationwide, but we talk a lot about kind of the spiritual benefits of the ocean to people. But, we have to decide. I think my personal view is to, when thinking of these strategies, I'd like to say, okay, first, do no harm, which is to first do no more additional change that would be harmful to these ecosystems that we care about. But if that's not possible, then we need to understand kind of what are the risks involved fully. And then also, what do we want to preserve? What is the priority there? And the we is the big question, right? So who is that when we're talking about the global commons of the ocean? And that's a big question for climate change overall. But I think that we have kind of the international infrastructure to kind of talk about these things when we talk about climate research and mitigation activities more broadly. But for oceans, I think this is still something relatively new. So to David's point about bringing in more stakeholders is just a fancy word for different groups of people with different ideas, right? Different priorities. So it's tough, but I think we're starting to approach that now.
Yeah, that's right. Stakeholder is just a fancy word. So let's move on to the other paper we were going to discuss, which is the potential negative effects of ocean afforestation on offshore ecosystems. I mean, I think, David, you kind of already touched on this a little bit, but, planting large kelp arrays obviously will have environmental impacts in the ocean. So what are some of the ways that these kelp forests could affect surrounding ecosystems in both a positive and a negative way?
In terms of positive, I mean, if we're talking about doing this at scale, like gigaton scale, I'm not sure, that we might have benefits for carbon removal if that comes to fruition. But in terms of like other benefits, like kelp, we think of kelp forests like, as a place where other organisms can thrive. Like you can imagine this makes sense in certain sort of offshore regions, but if the entire ocean was like that, I'm not sure we would say, well, that's beneficial, right? So it's really in the scaling, and they don't make this point in the paper, but they do make the point that it's when you scale things that you see these effects. And so, they talked about like competition between macroalgae and microalgae, like chemical competition. They talk about like things that grow in coastal areas getting transported offshore, like microbial communities and things like this. So you're talking about invasive species, right? And then one of the big things that our student found is that when you consider nutrient removal, so you take away the nutrients from the microalgae, then maybe the microalgae isn't growing and the things that feed on the microalgae won't grow, right? So you're affecting higher trophic levels as well. So maybe you'll have less fish because maybe fish does not eat kelp. And then, there are other effects like releasing volatile organic carbon or compounds to the atmosphere, or dissolve organic carbon from macroalgae, a lot of that going into the water, and how does that affect the microbial community again? And then there's a paper by the same group of authors about sargassum, where they pointed out that this could affect the albedo of the ocean. But also, people have in this paper, they also mention it, the light penetration into the water, and that would affect, productivity as well in other organisms. So, when you do it at project scale, this doesn't seem like a big deal, but then, we have to look at what does it mean to do this at gigaton scale, like every year. It's not just once, right? And I think this is where I guess the power of this paper is really pointing out, like, hey, when you scale things, that's when, a lot of these problems emerge.
That was really a good distinction, David, because I think you're right. Oftentimes right now, even though we're talking about gigatons, we're only looking at small projects that are very narrowly focused, and it is hard to extrapolate what it means. And so these papers are really important in helping us constantly bring our focus back a little broader about what we are doing. Shannon, can you tell us what the researchers proposed for measuring the ecological effects of ocean afforestation and what you thought of this approach, especially given in light of your, work when you are identifying projects for Stripe and working with them?
Yeah, so I think in terms of, at least when they talk about kind of the metrics for testing and so on, I kind of liked I definitely support their approach of kind of looking at different ways to capture kind of what's going on in these ecosystems. So again, the modeling side of things, which allows you to turn the dials up and kind of scale up as much as you want to, hypothetically. But understanding that those models, for example, could have assumptions about how biogeochemistry is going to work in the real ocean that may not bear out in practice. So therefore, you also need kind of laboratory experiments and field engagement as well, to try to see what those kind of unknowns are, and see how different systems interact in the system in different ways. So I definitely think kind of that multi-pronged approach of the modeling, lab, and field work is definitely all necessary.
So I want to transition to our last topic of the day, which is kind of talking about Ocean CDR and a just transition. I mean, we've talked about it a little bit throughout the show, but Shannon, as I mentioned earlier, you have evaluated Ocean CDR projects for Stipe. You obviously have studied blue carbon ecosystems. That's your expertise. What has that work taught you about when you assess these kind of proposals, in the ability of Ocean CDR to be scaled up, and how you balance what you talked about, like the spiritual importance of the ocean to particularly onshore, communities, versus the impact that CDR could have to their spiritual use of the ocean?
Mm-hmm. Yeah, those are truly questions. I think, first off, I think from my experience in kind of reviewing applications for demonstration projects is that demonstration is really the key word there. I don't think Ocean CDR is ready for scaling up as we're at now. There's a lot of more analysis that we need to do, and a lot of risk that we need to understand better. It doesn't mean that we don't need to explore, and that we need to, I'm totally supportive of an all hands on deck approach to tackling the climate crisis. It just means that we need to be clear and intentional about what we're saying when we're offering purchases for carbon removal. And in the ocean space, I think we're offering experimentation, demonstrations, and opportunities for more analysis and more information on where to go. I definitely feel like there's a lot of well-intentioned folks out there who may have, some groups may have a kind of a shallower understanding of kind of ocean physics and kind of how the ecosystems work. And that's totally fair. And I think some of that's on us, honestly, in the scientific community. I think there has been kind of a long-standing feeling that, we're scientists, we just do the research, we get the data, and what you do with it is kind of your business, and we don't weigh in. And I think that attitude is starting to change, and I think it needs to change. I think big oceanographic research groups and institutions are starting to really understand the need to be involved at the kind of beginning stage in discussions with different companies, different actors in these spaces. And that means maybe changing a little bit about how we communicate our science and the spaces in which we show up to talk about our science, even how we develop our research programs, or how we go for different funding for kind of more applied projects that will help serve this space. Because again, it is really an all hands on deck problem. So yeah, I think the norms need to change kind of in our field, and they are changing in terms of, again, to bring back the stakeholders, get everybody in the same room and talking. Yeah, I'm not sure if I really addressed the spiritual side of that, but I guess that's just some of my kind of thoughts on where science can help keep pace with where different actors are trying to go in terms of these projects.
That's okay. You couldn't answer that question. It was sort of a trick question. I always am asking it because I want someone to give me an easy answer, but I think the bottom line is it's not easy. It's always about the trade-offs. So David, you talked on your Twitter handle about the advantages of reducing emissions faster than relying on CDR. So from the perspective of scientific research, how would you like to see resources directed towards evaluating CDR? Should we continue to only focus or mainly focus on maintaining existing research on things like emission reductions and ecosystem protection, or is there a different way that you would allocate the rather small research dollars that are out there?
I'm not sure if we need to have more research into emission reduction and protecting ecosystems. We know that those things should be done, right? So I don't think it's a competition between, in terms of financial resources, between decarbonization and CDR. It's really maybe our attention, right? Like us thinking that, hey, CDR is going to take care of atmospheric CO2, so we don't have to worry about, our continued emissions. And that's where I guess I tweeted initially that I think you're referring to some tweet where I say, it's much easier to reduce emissions than to, remove carbon dioxide from the atmosphere. And I think that's very true. Like if you look at any of these examples that I've tweeted, it's just the scale is massive. And I don't think people really think about that until you really go through the calculations to see whether it's really possible to do these things, right? To give you an example, I talked about kelp. And not all the potential companies out there talk about harvesting kelp, but some do. And that's the best way to do one part of MRV, one part of the monitoring, reporting, and verification is to just remove the kelp from the ocean, right? Because if you're waiting for it to sink, then you don't know how much sinks, where it goes, and so on. And that's where that initial Dave Siegel paper might come in. But let's say if you harvest the kelp, if we want to remove 1 gigaton of CO2 from the ocean, not from the atmosphere, right, from the ocean, and there's a dry weight to wet weight ratio of about 14%, and then the carbon content of dry kelp is about 30%. So if you want to remove 1 gigaton of CO2, it means removing 6.5 gigatons of kelp. And what is 6.5 gigatons of kelp? That's almost 70 times more weight than the annual fish catch, right? So you would need a fleet of ships, maybe, 70 times more ships to just get kelp out of the ocean, which gives you a sense of the scale, right? And that's only 1 gigaton of CO2 from the ocean. And if you think that maybe only removes 40% from the atmosphere, then you need whatever 70 divided by 0.4 is, that amount of fishing boats and resources. So it's not, as long as we're releasing CO2 at a rate of whatever 38 gigatons of CO2 a year, we're not going to be able to keep up with that, with that emission. So that's why I think it's much easier if we focus on emission reduction. But in terms of devoting resources, I think we need to do research on CDR, because even after we get to net zero in terms of emissions, we still need to remove some CO2 from the atmosphere, and that's where the CDR will come in.
Thank you, David. That was actually kind of mind-blowing for me when you walked through those numbers and just the scale of it. I mean, I know the ocean is vast, but still it's sort of hard to even envision. All right, last question for you both. A coalition of companies led by Stripe recently announced, nearly $1 billion of commitment to buying carbon removals. Obviously, the IPCC report on mitigation from April said that CDR will be needed to meet climate goals, to David's point of removing legacy emissions. So, and on one of my earlier shows, the Noya CEO, Josh Santos, said that many companies haven't gone public yet, but are looking at CDR plans. So it certainly seems like CDR is growing in the consciousness of the corporate community and the policymakers. What recommendations would you give to a company or, the government that wants to think about net zero with CDR, particularly the types of guardrails that you'd want to be putting around Ocean CDR to ensure that they do not become extractive like other industries have in the past? And so I will start with Shannon on this one and then end with you, David.
Sure. I'd say for companies, continue to try to get researchers, and maybe like talking about parochial interests here, but get researchers, continue to work with folks on your team and to help kind of work with these issues of MRV and understanding some of the ecological risks and buying down some of that risk. I think folks like Ocean Visions that you discussed on the podcast before, kind of good types of organizations and models of how you can kind of create those networks so that the research and the kind of progress on the ground is trying to keep pace with each other. And I think that builds that kind of credibility and demonstration that you can actually put up what you say you want to do is going to help your bottom line as a company too, right? So I'd say that for companies and for investors looking at which kind of companies to support, that's something that I would love to continue to see growth on. For governments, likewise, kind of, I think kind of showing up for what you want to see, also in terms of kind of some of the justice issues of that, making sure that even as kind of standards on how you do some of these activities are developed, that you're kind of leaning on your activities or your kind of collaboration with different international structures to make sure that the standards of how you're working in different places are common enough such that you don't have companies that wind up kind of just shopping around for who lets them do kind of the most without understanding the kind of full impacts of that. I think that's a really important thing, and trying to, I would, of course, I think a lot about justice impacts of things, and kind of, again, looking through some of the proposals that I've seen, a lot of the work is being proposed to be done in places in the world that have contributed historically the least to carbon emissions, but could bear the brunt of the impacts, or are already bearing many of the impacts, let's be clear. And, I think, again, thinking about and avoiding repeating mistakes of the past, now is the time, while these projects and these companies are getting developed, to make sure that folks in these countries that the work is being kind of based out of, that they're also benefiting financially from the growth in this area. That I think is so important, and also so tricky to try to kind of regulate. But I think that, if you're talking about government matching schemes, for example, if governments are providing grants to different organizations that are doing work, matching private funding, put the requirements kind of for those types of good actions that we want to see, both from a ecological best practice and all environmental best practice, but also a community and sociological kind of best practice standards. Write those requirements into the grants. And I think you're starting to see that DOE and other actors have those kind of things that are in place for different types of activities. And as Ocean CDR is growing, I think you should have that in place as well.
Thanks, Shannon. David, you have the last word.
Okay, I think that was great from Shannon. I don't have much to add to that, except that I think we need some sort of carbon market, right? Or there needs to be a carbon tax or something to, speaking from the point of view of what government should do. Otherwise, how do you incentivize people to pay for these things? And certainly, I think we need to learn from the past. You're talking about how to not make it become an extractive industry. So we again, this is not the job of a scientist, right? There are people who specialize in these things. They need to look at what mistakes were made in the past and make sure that we avoid making those mistakes up front. But I want to push back on the phrasing of the question of, what recommendation would you give a company that wants to achieve net zero with CDR? There is no achieving net zero without eliminating fossil fuels, period, right? CDR is not there to allow us to achieve net zero. And I think that's really important.
Fair enough, David. Fair enough. Good point. And I agree. You have to figure out what to do with fossil fuels first and foremost. With that, thank you both for joining us. I really enjoyed the conversation and how well you broke down a super complex topic into a very understandable conversation. And I hope you both have a wonderful weekend. So thank you both for joining.
Thanks for having us.
Yes, thanks again.
Thanks so much for listening to Carbon Removal Newsroom. If you like the show, the best way you can help us is by giving us a great rating and review in Apple Podcast, following the show on Spotify, and by sharing the show on social media. Tell your friends and help us spread the word about what's happening in the world of carbon removal.